Okay, we're going to start 14.1, and this is an introduction to rational expressions. So a rational expression can best be defined as the quotient, that's supposed to be p of x, not p of q, is the quotient of two polynomials. So p of x over q of x, where, of course, q of x is not equal to 0. So since whole numbers are also polynomials, this includes all what we would call normal fractions. And more generally, it includes all rational numbers. So another word for a regular rational number is a rational expression. Although, as you'll soon see, we're actually dealing with some interesting rational expressions. Let's go over this rule right here that they're suggesting first. I've gone over it in the past, but clearly it's something that they're reminding us. Rule for negatives. It's a really simple rule, and I'm hoping that when I write this, you'll say, yeah, I got that. So minus a divided by b, where a is a polynomial, where this is a rational expression. So you can consider a as a possible polynomial and b is a non-zero polynomial. So that is the additive inverse of a divided by b. But that's the same thing as minus a over b. In other words, I can take the negative sign and put it in the numerator, or if I want, I can take the negative sign and put it in the denominator. All three of these are equivalent. And the reason we're showing you that is it's going to be something we'll be using. So let's look at some actual examples. I would take this up. So the first thing we're going to do is we're just going to look at some rational expressions and evaluate them for the given values of x. So this is 1a. And recall, I'm just doing this once. If px is equal to x plus 4, that's clearly a polynomial. And if qx is equal to x minus 2, then the rational expression formed by px divided by qx is given by x plus 4 divided by x minus 2. So this is our first new type of a rational expression. So we want to evaluate this when x is equal to 4. So we just literally plug in the value of 4 for x. And I get 4 plus 4 is 8. 4 minus 2 is 2. And that simplifies to 4. So that's not so bad. Just regular evaluations. So here our next rational expression is given by the polynomial y squared in the numerator and y minus 3 in the denominator. And we want to find its value when y is equal to 5. So again, we just replace the symbol y with 5. And then we simplify. 5 squared is 25. And 5 minus 3 is 2. And that's a perfectly fine answer. If you want to change it into a mixed number, that's up to you. I'm perfectly fine with that answer. And we will do 1C. We have a degree 2 polynomial in our numerator and a degree 2 polynomial in our denominator. And we want to know its value when x is equal to minus 3. So again, what we do is literally I take x. Now x is the base, so minus 3 is going to be my base. And to indicate it as a base, I need to put it in parentheses because it's raised to the second power. Plus 5 times minus 3 minus 2 over, again, minus 3 squared minus, remember minus 3 has to bring its negative sign with it. It can't use the one that's already there, minus 2. Now do not try to cancel out the minus 3 squared in the numerator and the minus 3 squared in the denominator. That's a common error, and it's completely wrong. Our only option is to evaluate the numerator and then evaluate the denominator. So minus 3 squared is minus 3 times 3, so that gives me 9. 5 times minus 3 is minus 15, and then I'm subtracting a 2. Down on the bottom, again, I have 9. Minus a minus 3 is plus 3, minus 2. And now all I have to do is simplify the numerator. So 9 minus 15 minus 2 is the same as 9 minus 17, which is minus 8. And 9 plus 3 is 12 minus 2, and that's 10. And that can be reduced to divide the numerator and the denominator by 2. So minus 8 divided by 2 is minus 4. And 10 divided by 2 is 5. And notice where the negative is, it's in the top. It can be written as the negative on the level with the division sign. Okay. So notice, just a little bit of a reminder, that our rational expression P over Q, P of x over Q of x, where these are just two polynomials, requires that Q of x is not equal to 0. So let's go back to our very first example, a really simple one. And let's look at, again, this. And let's try to evaluate it when x is equal to 2. I hope you can read that. It's kind of, you don't see screen glare, and that's kind of nice. So when x is equal to 2, I just replace my x with my 2. So that gives 6 divided by 0. This is undefined. Division by 0 is undefined. So this rational expression is not defined when x is equal to 2. So that's what we're pretty much doing in the next set of exercises, is finding the values for which each rational expression is not defined. So you should kind of see what you're supposed to do, but I'm going to go ahead and write what you're supposed to do, because sometimes it's kind of nice to have the recipe. To find values, and notice I say values because there could be more than one, for which a rational expression is undefined. And that's what we're asked to do. This will be something you'll be doing for also in intermediate algebra. I just graded exams where they were asked to do this very thing. Here's what you do. Set the denominator equal to 0. Solve for the variable. There's only going to be one variable. We're only dealing with polynomials in one variable at this point. 2, exclude those variable values. As possible values for which the rational expression is defined. So you exclude them, but here, literally what they only want you to do is find those variables. And then once you find the variables, you exclude them. But all they want here is for you to find the variables. In other words, what are the solutions for number 1? So they're concentrated on step number 1, and clearly that's where all the work occurs. As soon as you find the variables for which the denominator is equal to 0, then you know that those have to be excluded. So 2a, we have 7 over the polynomial in the variable a. So what do? 1 says, I set the denominator equal to 0 and solve for a. Divide both sides through by 4. So a is equal to 0 divided by 4, which is equal to 0. So a equals to 0 is the value of a for which the rational expression is undefined. So that's all they're asking for here. And really that's all you do is just simply say this is defined for every a except this one. So defined for every a except this one. So let's do number B. We have 3y squared. Notice it doesn't matter what you have in the numerator. The numerator does not come into play in this process. So what do? Here is the denominator right here. We set it equal to 0. So the only way we have to solve this is, because this is a degree 2 polynomial, is to first factor it. And this is easily factored because the greatest common factor is y. So now I use the zero product theorem. So that tells me y is equal to 0, or y minus 5 is equal to 0, which tells me y is equal to 5. So the values which must be excluded are y is equal to 0 and y is equal to 5. And for number C, so notice how we get tools and then we use them immediately. So we just learned how to factor polynomials, degree 2 polynomials, and then solve equations where the degree 2 polynomial was equal to 0. And that's what we do here. Again, it makes no difference what the numerator is. We seriously only look at the denominator. So I have to solve the equation 2x squared minus 7x minus 4 is equal to 0. And you guys literally only have one way to do this. And you have to factor it. So we're going to factor this polynomial. So I want 2x squared, a minus 4, and a minus 7x. So I have only one choice for the first row, 2x and x. That's a negative, so exactly one of the factors have to be negative. We could do minus 2 and 2. And that's negative down here. So I'm thinking we better do minus 4 and 1. And that gives us minus 8x plus x, and that gives us 7x. So my factorization, remember, don't forget to extract the correct factorization. I mean, you can do all the work and get your table filled in. Then if you forget to write down the factorization that results from it, then you've messed up. All of that work was for nothing. So it's 2x plus 1 and x minus 4. So as always, we set each one of these equal to 0. So that means 2x plus 1 is equal to 0, or x minus 4 is equal to 0. I'm not going to go through the steps to solve this first one. You should be able to solve it. This is a simple linear equation. So I'm not filling in the blanks. You all need to fill in the blanks, but I'm going to declare the answer is minus 1/2. And down here it's really simple. I just move the minus 4 to the other side and it becomes positive. So those are our two values for which the rational expression is undefined. Let's turn the page. So just like every type of, think about what's coming. Just about everything we do with fractions, we're going to be doing with rational expressions. So let's remind you. Suppose I have 4 divided by 12. We know we can reduce that, right? And how do we reduce it? We factor 4. 4 is equal to 2 times 2. And we factor 12. 12 is equal to 2 times 2 times 3. And then we cancel out any common factors. So we can cancel out both of these 2's. Now when you cancel them out, they become 1's, not 0's. So their answer is 1/3. We're going to be doing the same thing here. We're going to be canceling out factors. Now, of course, in this particular one, I could have just as easily written 12 is 4 times 3 and canceled out the 4's, and I got 1/3. The same is going to be true here, but the point is you have to cancel out every factor in the numerator that is also found in the denominator. And sometimes the best way to do that is to break it down into primes. And remember, if we have a polynomial, a linear polynomial, mx plus b, that's a degree 1 polynomial, where the GCF, greatest common factor, of m and b is equal to 1, then the polynomial, if you want to put it in parentheses to remember it's being treated as a factor, you can, that polynomial is prime. In particular, we call those prime linear factors. And when I write it as mx plus b, I hope that recalls that if I set the answer equal to y, I get a straight line, and that's the reason it's a linear factor. So let's just do some of these problems. So this is 3a. So I have y plus 3. So this is really nice that it's already factored for us. When it's given in factored form, it's really simple. All you have to do is cancel out any common factors. And the factor of y minus 1 is the same as y minus 1. So the end result is y plus 3 divided by y plus 5. Now, if you want to keep these in parentheses, you can, but you need to be able to understand what I just wrote and what this is here are identical, because when I enclose two terms in parentheses and there's no operation outside of those parentheses, like a minus 1 or a multiply by 7 or something like that, then they're identical. I've not changed the value at all. Now here for number B, I'm going to remind you, this is very important that you're able to factor out a negative. So factor out a negative. So if you have a sum A plus B, I can factor out a negative by changing the signs on each one of the terms. So that's the rule right there. Now remember, when I write A, that doesn't mean A is positive. A might very well be negative 3, and B might be negative 3. So let's do a few examples. Let's factor out a negative when I have minus 3 plus 5. Well, okay, I put my negative sign there, put my parentheses there. I change the sign on minus 3 to a plus, so I don't write anything, and I change the sign to 5 to a minus 5. Let's do x minus 5. Factor out a negative. That's the same as minus x plus 5. And many times you will see that written as 5 minus x. All I did is use the commutative property on what's inside the parentheses. So we're going to be factoring out negatives. And we're actually going to be doing that on this very next problem, which is 3b. 6 minus a over a minus 6. Notice my terms have 6 and an a, but they differ by sign. So I'm going to factor out a negative. I'm going to factor out a negative on the top term. So I'm going to keep the bottom as it is, a minus 6, factoring out a negative. So the 6 becomes a minus 6, and the a becomes a plus a. And then I'm going to rearrange those factors. Since that's a plus a, it's going to come up front. It's going to be a minus 6. I just rearranged the terms just like I did over here. And then I have a minus 6 on the bottom. And it's probably helpful if you put those in parentheses. And the reason being, I don't want any canceling out of the a's in the top and the 6 in the bottoms. That's one of the, I don't know where students learn to do that, but it's terrible. So remember, when you cancel something out, what is left behind is a 1. And the negative is still here too. So this is the same as minus 1 divided by 1, which is simply the same as minus 1. That'll be a skill you'll use all the time. Make sure you understand that. Now we're going to simplify expressions based upon factoring out the greatest common factor, or just factoring in general. Factoring into primes, just like we do when we try to reduce fractions to their lowest terms. So this is 3c. I have minus 2x minus 2y and x plus y. Now here I'm going to note that my GCF is really 2, but it's okay to factor out a negative 2. And clearly a negative 2 is in both of those. So I'm going to factor out a negative 2. Minus 2x divided by minus 2 is x. Minus 2y divided by minus 2 is plus y. And then on the bottom, I'm going to write my x plus y in parentheses, so you acknowledge that it's a factor. It's to be taken as a group, not each one singly. And then I can cancel those out. Remember, when you cancel them out, they become ones. Not zeros, but ones. And the final answer is minus 2 times 1 divided by 1 is minus 2. Now let's do 3D. So we have again 6x minus 12 and 3x squared minus 12. In each case, we have to factor out the GCF of those two terms. The GCF of 6x and minus 12 is 6. So I'm factoring out that 6. 6x divided by 6 leaves me x. Minus 12 divided by 6 is minus 2. Now let's look down here. My GCF is going to be a 3. So I'm going to write down my 3, and then my parentheses. 3x squared divided by 3 leaves me an x squared. Minus 12 divided by 3 leaves me a minus 6. Well, what else can I do? Well, 6 divided by 3 is 2. And we're not hardly done because, so remember, I just notice, just as a reminder, this rational expression right here is the same as 6/3 by fraction multiplication over x minus times x minus 2 over x squared minus 6. So 6 divided by 3 is equal to 2, and 2 is equal to 2 over 1. So that's how I got the numerator over here. So this is just x squared minus, oh, that's sorry, it's supposed to be 4. I'll eventually catch it, hopefully. And it was easy to catch this time because I know what's coming up next. So pause right now and make sure you understand all of my moves right here. This is something you cannot be confused on. Me going from here, what I have here, to here, you've got to feel comfortable with. Because in intermediate algebra, we're just going to show you that. We're going to say you've already had time to master it. And if you're confused, guess what? You have to spend a lot of time until you're unconfused. So we can factor x squared minus 4, can't we? Because x squared minus 4 is equal to, I don't want to rewrite exactly what I have already, x squared minus 2 squared. So that's a difference of perfect squares. So that means this can be rewritten as 2. Didn't do anything to simplify the numerator, but the denominator is now factored as x minus 2 times x plus 2. And now I have a factor that I can cancel. I can cancel the x minus 2 factors. And the end result is 2 stays on the numerator, and I have an x plus 2 in the denominator. And if you want to get in the habit of writing it in parentheses, I think that's an absolutely good idea because it reminds you whoops, not that one, this one. It reminds you that that is a factor that should be taken by itself. So this is 3e. So look, we're going to have to factor a polynomial in the variable y on the top. And then I'm going to have to factor another trinomial in the variable y on the bottom. So here's what I'm going to do. I'm going to do the top one. You all work on the bottom one. I'm just going to give you the answer for the bottom one. So that means at some point you'll want to pause this and figure out the factorization of the denominator. So that's going to be y squared, 15, and 8y. It's kind of nice when the leading coefficient is 1, because I only have one option for that first top row. In 15, I'm going to say 3 times 5 gives me 15, so that gives me 3y plus 5y, so that's equal to 8y. So my factorization for the numerator is y plus 5 times y plus 3. Whoops. Let's just take it all the way up here. And for the factorization on the denominator, I'm hoping you get y plus 3 times y plus 6. If not, do it again till you find your error. So now we're going to cancel out like factors. The y plus 3 cancels, the y plus 3 cancels. The end result is y plus 5 over y plus 6. And the reason I'm telling you just to keep them in parentheses there is because so many students want to do this kind of thing. Y plus 5 over y plus 6. Oh, those two cancel. It's equal to 5, 6. No way. You can figure out how wrong that is by just doing something like 2 plus 2 divided by 2 minus 1. Well, if I cancel out the 2's, my answer is going to be minus 2. Instead, if I do it the right way, 2 plus 2 is equal to 4. 2 minus 1 is 1. And minus 2 is clearly not equal to 4. So don't do that. And if you keep them enclosed in your parentheses there, it will help ease that temptation, or so I want to believe, until the temptation is forever and ever and ever gone. That's what we're getting to. So this next one is going to be one that I would not give you on an exam. It's in two variables, but we're going to do it here, and it won't be on your final exam. And if it's in your homework, it's there by mistake, but it's worth doing because we definitely have the tools to do it. So this is 3F. Maybe it's 3F. 3F. There we go. So the problem is the factorization of the numerator. The denominator is not going to be hard. So let's go ahead and let's factor the denominator. What do? We always look for a greatest common factor. Both of those terms have an x, so I pull out that x. X squared divided by x gives me x. 5x divided by x gives me 5. Okay, that's not so bad. So let's come down here and let's work on the factorization of the numerator. And the first thing that should strike you is the big huge clue is it's given to you as 4 terms. So this is going to require factorization by groups. This is my first group. This is my second group. So what do? We factor out the greatest common factor of each group. The greatest common factor of x squared and minus x is x. So x squared divided by x is x, minus xy divided by x is minus y. The greatest common factor of the next group is 5. 5 is the only factor shared in those two terms. So 5x divided by 5 is x. Minus 5y divided by 5 is minus y. And now we're ready to go again. I've taken 4 terms, and now I only have 2 terms. So I've reduced my terms down by half. Now, of these 2 terms, the only common factor is this factor, x minus y. So I'll bring it out, and now I just find out what remains. So x times x minus y divided by x minus y is x. 5 times x minus y divided by x minus y is 5. And this is what goes in my numerator. X minus y times x plus 5. And sure enough, it was fruitful in the end. I mean, of course it's going to be. These are literally created so that you're going to get something. So you can you can cancel the x plus 5 and the x plus 5 factors, and your end result is x minus y. Go ahead and leave it in parentheses if you want, divided by x. Okay, now let's do number 4. 4 is a great little, I'm not going to do but one of these. It's a fun little exercise. They want you to list 4 equivalent forms for each rational expression. And there's way more than 4. So it's rewriting something just by rearranging terms or introducing or factoring out a negative, such that what I rewrite is algebraically the same. So 4a, I'm just going to do a whole bunch of 4a's, and you all can look at the others. So I have minus, it's even with the division line, x minus 2 over x plus 5. So the first equivalent form is I'm going to take the minus and I'm going to put it up here. Notice when I put it in the numerator, I have to write that numerator as a fraction. So I'm just going to counsel you just immediately put those parentheses around there. So there's 1. It just resulted by taking the minus sign that's level with the division line and putting it in the numerator. Well, let's do another one along those same lines of reasoning. X minus 2, but this time I'm going to take the minus sign and I'm going to put it on the denominator. So, okay, there's 2 equivalent forms. How can I get 2 more? I'm going to put that in parentheses. Let's multiply through by the minus 1. So minus x plus 2 is, how do I remove the negative? I have to change the sign of each of those terms. And let me give me some more room. And normally, that's perfectly fine, but normally it would be written as 2 minus x over x plus 5, or it might actually be written as 2 minus x over x plus 5, and you've got to remember those are to be taken as a whole. Well, let's do the same thing down here, except this time I'm going to leave my numerator and I'm going to distribute, or I'm going to take away the negative by multiplying both terms by minus 1. So remember, one way to think of minus x plus 5 is it's minus 1 times x plus 5, which is the same as minus 1 times x, which is minus x. Minus 1 times 5 is minus 5. And I just did it, minus x minus 5. And you can put the whole thing in parentheses and that's the fourth. So there's 1, 2, 3, and 4. All four of those are identical to the first one. And in certain cases, you may need number 4 rather than the original form. In other cases, you may need to see the original form is form number 2. Okay, that is it for section 14.1.